All right, so here is the outline for today. I've got a good hour here, so I'm going to be hard pressed to get this in an hour probably. I do want to do a quick overview just to kind of start out and talk about just what latex modified concrete is and what makes it different than some of the other cementitious overlays out there. Most of my time I'm going to go through the North Carolina DOT specification and just kind of tie it into the general installation process. So I will touch briefly on the rapid set mixes, both the very early strength and the early strength. At the end, I've got a section that I talk about pitfalls, things to watch for, kind of some troubleshooting things, kind of tips of the trade. And then at the end, I'll review a few resources that are out there that can help you out in the field. So, okay, latex modified concrete. It's a Portland cement-based concrete. The only thing different about it compared to conventional Portland cement concrete is the introduction of the admixture of the styrene butadiene latex, which is suspended in water. This is introduced into the mix in an emulsion form. What it does is it serves to replace part of the mixing water, which in turn is reducing the water-cement ratio within our concrete. So this has the advantage of being able to help reduce the potential of dry shrinkage as there's less water remaining in the system requiring dissipation. These styrene butadiene particles are suspended in the water. They make up about 50% polymer solids. Polymers are what are referred to as hydrophobic. What that means is they're like water resistors. So as the latex emulsion is introduced into the mix and the water within that mix is being consumed in the hydration process, the polymers are trying to divest themselves from the emulsion, basically. So the polymer particles are attaching to other components of the mix, the aggregates, cement, even the deck and the reinforcing steel it's coming into contact with, whatever they can attach themselves to. And that includes themselves. So the polymers are even trying to fuse together to themselves, helping to create an elastic type membrane within the mix. So what's happening there is now you have something that's becoming more impenetrable for that water or chloride action to be able to penetrate down into your concrete. So it's functioning as a water reducing admixture, really in sense of what it's doing. And that gives it those unique characteristics that apply to water-reducing admixtures, which would be helping to improve our paste quality, give a higher density paste, lower permeability concrete, which is what we want, but then also improves the bondability of the concrete to the deck and the reinforcing steel and reduces the volume change between the wetting and the drying period of the latex concrete. Look at the emulsion. It will have a white, milky appearance to it. Look at it up close under a microscope. You see the polymers within the emulsion. Notice how the particles themselves are trying to attract or clump together to each other. So they're trying to build kind of that membrane network within the concrete. So I'll tack this session kind of similar to what I did yesterday. Kind of work my way through the main parts of your spec and then simultaneously kind of go over the general process and the best practice applications that are out there. So again, I broke it down into headings within your spec, and I'll look at each of the applicable parts here. So the first section deals with quality control, and there are three minor sections within there that deal with one, pre-construction conference meeting, the QC, and then also your equipment. Not sure to what extent your pre-construction meeting will go into the nuts and bolts of the process. Probably depends on the engineer, but in case you don't have a good detailed list, I think this listing here that I have up on the screen is a good checklist, so to speak, of various things that need to be reviewed and enforced for the installation process. You see, I broke it down into two columns here. One that deals with the items you need to discuss with the contractor before the pour is made, and then on the right side, the listing of those items that need to be a focus point during the actual installation process itself. So this may not be all inclusive, but I think it's a good start for you out there to kind of take a look at the various things that you want to be aware of on the job. Many of these items I'll be touching on as we go along here. So likewise, the QC plan, equipment, I think those are better addressed in some of the other sections as we go along. So I'll just go ahead and move right into materials. And for an LMC mix, it's the normal components you'd find in conventional Portland cement concrete, with the exception of the latex modifier that's added in. Obviously, you need compliance with regard to your state specification on the various materials in the mix. The thing that makes LMC a little tricky is that this is going to be volumetrically mixed at the job site. So essentially, you have your own batching operation. That means whereas with conventional ready mix, all the quality control for that would take place at the plant. Now you're having to take care of that out at the job site. So that can get tough to do and still provide high quality product out there for you. So out on site, the contractor, he's going to need to appropriately store this material. So coarse and fine aggregates, for instance, ideally that's going to be right at the bridge or in a vicinity that's fairly close to the bridge to minimize the travel to and from the bridge during the pour. Aggregates are obviously going to need to be stored in areas separately and in a manner which will keep them apart and avoided from contamination from the environment around. The other key is going to be getting a good uniform moisture content. So you have your aggregates on site, you need to provide a location that's going to be somewhere where it can be properly maintained. So the moisture content is going to be important also. May require the use of sprinklers or another means to apply water to the stockpile where the aggregates are stored. And then covering up the stockpile with plastic helps keep in the moisture content, prevent it from drying out, also keep it from getting contaminated. In periods of very wet weather, the aggregates may need to be protected to keep them from incurring excess moisture from rain events. Also, where possible, especially where it's hot, try to get the stockpile in a shaded area to help to cut down on the heating of the material. Plus, the use of a white plastic can reflect the sunlight. So the latex modifier, a little more about it. Federal Highway conducted research on latex and approved latexes to conform to Federal Highway research document 7835 for styrene butadiene latex emulsion. 46% minimum solids by weight. I think the North Carolina DOT spec actually calls for 46.5% minimum up to a maximum of 49%. Some of the other do's and don'ts that often get ignored on the job sites, the emulsion should be stored between 35 and 85 degrees and definitely not permitted to freeze. So in a hot summer, that upper limit can be exceeded pretty easily unless there's an appropriately insulated tank or a refrigeration unit or something like that on site. So, but keeping it out of direct sunlight can help too. Also make sure that the contractor mixes or agitates the latex prior to using it, especially if it has sat around on the site for a few weeks or months or however long it's been out there. And then you don't want to mix brands of latex. There's only two suppliers of latex, the latex modifier. One is BASF, the other is Trinseo. Cement, same thing. You're going to have to store it. You're going to need something weather tight, maybe a silo or a tanker on site. And then within the mobile mixer itself, those low pressure aeration with dry air vibration to help keep the cement from trying to bridge within the compartment and make sure accurate metering of the cement's occurring. So outside of the latex, though, there's no other admixtures within the concrete. There's no air entraining agent in latex modified concrete, but air will be entrapped just normally in the process. If it becomes excessive, defoamers can be used to help reduce that. But you do want to use a defoamer recommended by the latex manufacturer. Illinois DOT, they've been using fibers in some of their mixes. I think they're the only state that's doing that. That requires a special fiber cutter that's added to the mobile mixer. But other than that, you don't have anything additional other than your basic components there. So I'll jump over to mix design, talk about it briefly. Just a look at the North Carolina design. Pretty much per recommendations of the latex manufacturers. 7-sack mix, 24.5 gallons of latex emulsion incorporated into it. Air and slump ranges pretty much normal, 3 to 6 is common. North Carolina is a little more restrictive on the amount of fine aggregate that can be used in the mix, of 50 to 55% as a total aggregate by weight. Some agencies will allow a little more fine aggregate. You may see it up to 59%. The compressive strength requirements on the North Carolina side, only 3,007 days, and the water cement ratio maxes out at 0.4. That's pretty normal for latex mixes. It is real important that these mobile mixers meet certain specs. They need to be self-contained systems, self-propelled, capable of continuously mixing and dispensing the material. They also need to have meters to regulate the flow of water and be adjustable by the operator for variations in the moisture content that's encountered during the batching process. You want to have a minimum 6-yard mixer out there, and the mixer should also be able to print out tickets that are going to show the amount of cement and concrete that's mixed and dispensed. Vibrators are always good, especially for your aggregate bins, to ensure that material is being fed down to the conveyor system that runs through the truck. And you want to make sure the belts and augers are kept free of buildup or caking of material. It can mess with the calibration and the amount of material that's needed or being dispensed. So for latex, it's important that the tanks are on board and the system self-contained within the mobile mixer, including recirculation type systems. They should have relief valves, necessary pumps and strainers. The volumetric mixer itself, it's going to have these separate bins for all the various materials. So you can see the various bins and compartments for the mix ingredients in this particular slide. This one doesn't have the latex tank on it, but generally it would also be up front near the water tank. Just kind of gives you an idea of what a mixer truck might look like out there. And then what's happening is there's a system down at the belly of the truck. It's collecting the aggregates, the cement, running it to the back end with the collection or boot area where the water and the latex is added in, and there it's mixed within that boot, and the materials run up the auger, which is inclined away from the truck here in this picture, and then it dispenses it right out onto the deck. Do your testing of slump and air prior to backing out onto the deck if you're going to be mobilizing the truck directly to the back or to the front of the overlay operation. LMC tests a little different from normal Portland cement concrete. The material is dispensed and allowed to rest for 4 to 5 minutes. You'll find it's very flowable, so it needs just a bit to start to solidify. So the best way to test it is to run your air test while your material is resting there, and then run your slump. And generally good to pull your cylinders after a few yards or so has been dispensed off the truck, and you can get some good uniformly flowing mix. Yield testing is done with latex. Here's a example of that being done in the field. It's going to be a 1/4 yard box normally. You just fill the box with concrete. You can do that right in front of the area of discharge, and the box should be filled, and then the truck printout should verify that you have indeed dispensed a 1/4 yard of product. So the material from that box, you can use it right within the pour, then just lift off the mold, The idea is that what the truck says it's producing, in fact, it's matching our field results. That's what you're trying to verify with this particular test. So here's a surface prep now. Let's get into that. I want to touch on the key points for gaining an effective bond, because that's going to be your single most important feature that you're trying to achieve in the overlay installation. So first point is making sure you're not leaving weakened or deteriorated concrete in the substrate. That's going to be an obvious weak point under the overlay that can lead to failure. So, same with microfracturing. Hydrodemolition surface prep, what we talked about yesterday, should help to alleviate that. The overlay is only going to be as sound, though, as what it can adhere to. So a good surface roughness is desired, and that's where that hydrodemolition surface prep comes into play to give us the good mechanical grip between the overlay and the deck surface it's being applied to. You need a clean and saturated surface. Dirt and contaminants are going to be a bond breaker. And then too much puddling water also serves as a bond breaker or a weak plane for the concrete. The application of LMC on a good clean surface will allow the modifier to chemically draw itself into the deck surface. And tying it all together is just the use of good concreting practices out there. It all seems pretty basic and straightforward, and it is, but I thought it just deserved a little bit of emphasis here. So when you take all the steps to hit the details, it can go a long way to giving you a good quality surface. So final prep needs to be through abrasive or high pressure water blasting. Generally what that means is high pressure water blasting of an equivalent abrasive blast. And what that is a high pressure blast of 7,500 psi or more. That would be considered the industry equivalent to abrasive blasting. So it gets off all that remaining latents, any contaminants. It just helps to open up that surface immediately prior to conducting the pour. That high pressure water blasting is preferred normally because then you don't have to deal with all that sand or shot, that grit. It all gets into those crevices of that hydroed surface, and it's hard to get cleaned out of there. So make sure also that they're not bringing out, those garage pressure washers, those 3,000 psi pressure washers. That's not really the objective with that surface prep. And then when you are blasting, you're getting a good head start too on your deck saturation. If you're water blasting, okay, you're already watering the deck out there to a certain extent. So, the surface needs total saturation to the point of refusal or saturated surface dry condition, SSD condition. Especially in hot weather, it may take several hours of wetting just to cool down the deck. The North Carolina spec does require the deck surface maintain in this SSD condition for 12 hours. So that's a really good point in your spec. I like that. That's nice. Once it is saturated, it needs to get covered securely to keep that moisture locked in and not allow that deck to dry back out. And that covering also is serving to help keep the deck clean as well. Okay, so there's a look at the deck covered. And then we're ready for the placing and finishing requirements in the specification. Generally a self-propelled bidwell type unit with vibrating pan, rotating cylinder with auger or vibratory screed, plus a vibrating plan or a wet burlap drag. You want to get the finishing machine to the right elevation, obviously. That's going to be important. Dry run the entire deck to make sure the appropriate depth is achieved for grade control purposes. The North Carolina spec does require a filler block to help check that correct depth. Make sure your rollers are good and squared up to the inside rail that the carriage is going to ride on. This prevents the LMC from coming off the back end of the rollers and leaving those tailings. So see that you have enough rail too installed so that the machine will finish through the skew. You want the machine to run all the way through your skew and not do any hand finishing on that skewed port as much as you can control that. So surface prep dictates what we need to do for grouting. And the nice thing with hydrodemolition, grouting is not required on the horizontal portion where you're hydroblasting. It will be required still, though, on the vertical surfaces, such as along your curb lines, your joint areas, scuppers, areas like that. So now if you're just milling a surface, which some agencies still do that surface prep technique, they don't hydroblast, they'll mill it, which I think is a kind of a risky way to do it, but if you do that, you do have to grout your entire surface then to help with that interlock. You do have to make sure the grout is applied in a manner so as not to dry out, though, prior to the mix getting to it. That would create a bond breaker between the deck and the overlay. Grouting is conveniently done by taking a bristle broom and just pulling material from the pour and pulling it out ahead. So you kind of take the paste from the mix on the broom and then very liberally brush or scrub it back and forth into the surface. It's very important that this operation is kept close to the pour, though. If necessary, though, you can always go back and retreat it if it seems like they're getting a little too far out ahead, and it may potentially dry out. So they can go back as often as they need to and just continue to keep refreshing it. Rub it into the vertical faces at the joint. Make sure the vertical surfaces are getting blast clean, though, very well ahead of that, just like the horizontal surface. And maybe even more so, I'd say, at those areas. Those are areas that could use extra detail normally. Here you have a laborer just brushing in some grout at a drain area. And anytime you're dealing with volumetric mixing, it's really nice to have a good, experienced operator on the site dispensing the material for you. I'd recommend a shop vac to suck up your excess moisture that may be accumulating on the deck, and really stay vigilant on that. The crew often has a tendency to start off well, and then as the pour goes on and guys get tired and lose their focus, they can slack off that sometimes. So you do want some good looking mud out there, good flow, good consistency, something nice and fluid and flowing. Here you see several laborers up front. They're raking in front of the machine. But even ahead of this group, you're going to have people working. They're going to be pulling plastic up behind the mixer or ahead of the pour. You're going to have your shop vacs working to pick up excess water off the deck. Grouting work being done to spread your grout. So there's a lot of work that's being done in the whole process of this. You do notice a little bit of minor tailings off the screen in this picture. You want to kind of get your rollers there as level as you can. This is a better look, I think, as the machine starts out. You want to make sure those rollers are rolling smooth. You get rollers. You'll generally have drag pan and a burlap drag also kind of traversing back and forth across the surface to also seal up that concrete for you. If all these things are working correctly, really the intent is very little or no additional bull floating or finishing should be needed with the main surface. Any floating that is done should be done with a lighter weight Fresno type float. It can be beneficial too, and actually sometimes necessary, to use fogging equipment. If you're doing it right, though, it's kind of a catch-22. A little water can be a good thing. Latex seems to crave water. If it serves, as a kind of high humidity application, that's the key there. It's great for curing, but too much and too heavy can be detrimental and compromise the surface quality. When your air temperature and or your concrete temperature, for that matter, is hotter, the added humidity is helpful to help with controlling that evaporation rate that's occurring with the concrete, which I'm going to touch on here in just a second. Humidity is generally your friend. So when you do use fogging, it needs to be done as an attachment to the finished machine and not manually generally, which is how you often see it happening in the field. Some people don't like the fogging nozzle shooting straight down like it is here and prefer it points upwards. You're just trying to delicately mist it, not applying it as a finishing tool. So hand spraying can be very inconsistent, and usually it's being applied as much more than a mist is the problem with with when you hand spray it. So it should occur prior to the final finish and not behind the finish operation. So if fogging is to be used in the operation, you want to insist that the contractor have the equipment on the finish machine itself. For some applications, you'll also see the use of an evaporant to retard the concrete set, and it's supposed to inhibit the shrinkage cracking of the concrete. And that's a little different than fogging, and the latex manufacturer, he can help with specifying certain evaporants such as Confilm or something that can be used in that regard. Again, these are not finishing aids technically, and not really meant to be worked into the concrete, although often you see them kind of used in that capacity, it seems like. I know in North Carolina you don't do the wet tining for texturing, so that's kind of what they're doing here in this particular slide. You guys would specify the grinding and texturing after the cure period, but even just your normal finishing operation, you need to be careful that it's all completed promptly. If they are doing any floating, the latex will start to form a crust on it, at which point when you try to finish on that, it's going to want to tear. So the curing should be started prior to the concrete reaching that point for sure. And then speaking of curing, that's going to be one of the most critical aspects of the operation to get a good quality product. You can do everything perfect up to the point of curing, but if you fall short there, it can lead to a real mess on your deck. So some of the key things here: use good quality burlap. Make sure it's pre-soaked before the pour. Apply it over 100% of that deck surface. Definitely don't want it drying out or getting dry splotches in it during the wet cure period, which will be 48 hours of continuous wet curing. So cover your burlap with a layer of white polyethylene film to lock the moisture into. You want to carefully place the burlap with several laborers so as best as you can not mar the surface. So you'll lay it gently, as gently as you can, and also be sure to overlap the sections a good 6 inches or so to keep the edges sealed up good. Good rule of thumb is you want to get the burlap on within no more than a half hour or so of the concrete placement, but quicker is better, and definitely before seeing any drying out on the surface of the concrete, or before the latex surface develops that crust on it, like I mentioned. The contractor, he can't be out there right before the pour and start trying to wet burlap down. I've seen them try to take the burlap dry and just spray it down as they're laying it even. Just not a good practice at all. Definitely not acceptable. The best thing to do is get large tubs, soak it down the day before. Kind of like Seinfeld always said, you can't over wet, so wet it as much as you can. So soak that burlap down as long as you can to get it good and drenched, and then make it readily accessible in areas where the crew can get to it and install it. You'll often see it loaded onto the work bridge so the crew can just roll it on out there. That's a good way to go. But something very accessible to the crew, and make sure it's a dedicated crew. It's too critical to the operation for it just to be kind of an afterthought to the pour, which I've seen that on quite a few pours as well. So during the wet cure process, the white plastic is used to lock the moisture in during the cure process. White plastic's preferred for the curing to help reflect sunlight, especially in the hotter weather. Upon completion of the wet cure period, strip the plastic and the burlap, let the concrete air dry for 48 hours. That's the dry cure period then, where the LMC hardens and the film forming takes place. So let's look at some limitations of the operation as you guys have identified in your specifications. You want to be on the same page with how the material is going to be dispensed on your deck. Often trucks can be backed directly onto the deck and material placed directly in front of the finishing machine. It looks like in North Carolina that needs a special approval though to do that. If not allowed, the contractor will likely need to use motorized buggies to be able to cart his material up to the finish machine. The laborers can roll up that plastic as that concrete is placed in front of the finish machine, as they're doing kind of here in the background. Now, North Carolina, I noticed, has some very restrictive requirements with regard to weather, which is a good thing, I think. You need to be well aware of both the ambient and the deck temperature. Both can have an effect on the mix. The temps need to be in the 50 to 85 degree window for both. Wind speed up to 10 miles per hour max is allowed. There's also special requirements for temperatures dipping below the optimum temperature window after the pour, and latex is not to be poured if the temps are predicted to drop below 35 degrees within a 72-hour window. So you have quite a bit of things worked into your spec there that are, especially when you get into the spring and fall, those weather extremes kind of fluctuate a lot, so it can be tough. Nighttime pours are highly recommended, especially during summer months. You may have to pour at night to be able to meet the deck and the ambient temperature requirements. But in addition, the direct sunlight being kept off the pour, that can be an advantage for you with pouring latex. So evaporation rate, kind of mentioned that briefly earlier. Another one of those areas that can be neglected, but it's important to reducing the potential for the shrinkage cracking. Latex concrete, like conventional concrete, produces bleed water, just not as much. The atmospheric and site conditions allow for water to evaporate off the surface of the finished concrete. So when the rate of evaporation is occurring faster than the rate at which the bleed water is produced, that's what can lead to your shrinkage cracking in your concrete. So it's very important and a critical concept, this evaporation rate, but it often can be overlooked. Looks like you guys have great detail applied to that in the spec, which is nice. There is a method to the madness in determining just what that evaporation rate is. It involves knowing the air temperature, the relative humidity, the concrete temperature, and the wind speed. Now, ACI produced this nice little chart out here to help with determining the evaporation rate. And what you do is you just kind of start it and enter the chart with the air temperature in the upper left quadrant. In this case, we're using a 65 degrees as an example. With the known air temperature, you proceed vertically to the relative humidity. If the humidity is 40%, for instance, then you intersect your graph at that point, and then horizontally, you're going to track over to the right to the correct concrete temperature. In this case, it's 65 degrees. And then go down vertically to the wind velocity, determined here in this example to be 25 miles per hour. So for North Carolina, that would be a red flag right there. You couldn't pour. North Carolina spec says 10 miles per hour is the maximum allowable wind speed. From there, you move horizontally left to determine what the rate of evaporation will be. Here you can see it interpolates to at about 0.12, and the units are on there pounds per square foot per hour. So, and that would fall outside your North Carolina requirement, which would be 0.05. So pretty tough standard to meet. Most states usually use 0.1 for their standard. But you guys have 0.05 in North Carolina. Now, when the evaporation rate is at 0.15, it is kind of where it's anticipated that shrinkage cracking is likely to occur with LMC. Without other precautionary measures being taken. So. Some states will allow other measures to be used to get an acceptable rate, such as maybe setting up windbreaks or something like that to help with that. So the last part of your spec deals with measurement of payment, and 3 pay items in the North Carolina spec work good. I think you got it laid out pretty nice here. Pay item that handles the installation aspect of the overlay in a square yard format. So what it's going to cost that contractor to install it, do all of this setup for that. And then the actual cubic yard volume of concrete. So more your actual material cost, or at least that's how it should be bid, I would think, for this item. And then you have the texturing pay item that's done afterwards. So I'm going to jump gears here slightly and look at latex modified concrete very early strength. This is something North Carolina, I think, has used a lot. The VES mixes use a calcium sulfoaluminate cement. This allows for rapid strength gain in as little as 3 hours. So the characteristics of the concrete are really the same as your conventional latex, just the strength gain being the significant difference. One thing about the North Carolina spec, though, I noticed is the stipulation of experience by the contractors, which I think is a very wise thing to include. Few states do this. There are a couple that do. I think it's a smart thing to do. The contractors need to show what work they have done with these VES mixes in the last 5 years according to your specification. So I think that's a really nice little caveat you have in your spec there. These are also 7-sack mixes in favorable temperatures above 60 degrees. You should be able to obtain a 2,500 psi compressive strength in 3 hours. I would say you should probably try to limit pouring to 60 degrees and above with this mix, because when you get below that mix design, or when you get below that mix, it doesn't want to kick over as fast as when you have the higher temperatures. So when you get that cooler weather, you'll see a noticeable just difference in the strength gain that's being achieved there. So in warmer weather, you're just going to get the higher breaks and faster too. And something else in the North Carolina spec rather unique is the allowance for the rebound hammer testing to gauge comparable strength developments. That's interesting. I haven't really seen that in other specs. Since these surfaces are usually used in situations where the turnaround's quick, the time for saturation of the surface is scaled back to just 2 hours instead of the 12 hours that the Type 1 surface LMC would require. A few other unique features. North Carolina looks like you require 2 layers of wet burlap in lieu of the 1-layer wet burlap in the visqueen covering. So then a fogging system is used. There's also a stipulation that for thicker overlays, more wet cure time may be required as specified by the engineer. And with the quick opening, the grooving's delayed, but they need to do that within 7 days. Another interesting thing in the specification, that the evaporation rate, very key with these quick set systems, and as such, not only does the contractor need to determine the evaporation rate at the time of pour, but even within your specification, you're asking him to look and project conditions during the pour and determine if there's going to be any changing conditions that might hinder the placement. So that's kind of some good foresight there. In this particular case, the contractor does have the option to provide some other measures that he might be able to take to reduce that evaporation rate, such as like a windbreak or something like that. This is a night pour. It's not in North Carolina. I think this is in Kentucky. This is a VES pour. And note the mix here, no excess water in front of the pour. Now it looks like, and I wasn't for sure if you guys have actually started using the early strength mix yet, or if you're getting ready to, but you have a specification out there. The early strength mix is not quite as quick setting as the CSAs. So these mixes are going to be more with a Type 3 mix, these early strength mixes. The difference there, the biggest difference is going to be in the cure times. You have a 24-hour wet cure time and 24 hours of dry curing. So a little bit in between your CSA and your conventional Type 1 mix. The only thing I'd add probably is you probably want to check with your latex manufacturers to just verify the cement proposed is going to be compatible with the latex being used. Seems like that's come up on a job or two with compatibility issues for some reason on the cement. A little list of things to watch for now with the pours, and this would apply to really any of the mixes out there using the latex. You want to remember that the plastic has 2 functions, and the first one is it's used to adequately cover the deck surface in its entirety, to keep the deck saturated, keep that moisture locked in, keep the dirt and debris off it. This here, not good practice. Essentially, the contractor's missing the purpose here, and he's just laying a strip down the path where his mobile mixer is going to back up. He's locked in no moisture. It's preventing dirt. You know, it's not preventing the dirt and debris from getting on the deck. It's not enough to just go out there now and just start spraying down your deck in front of your pour because you have dry spots. That's not allowable or acceptable. So you do want 100% coverage of your surface. It's critical for the inspector also to be on top of the amount of water on the deck, not just if it's dried out, but not allowing the ponding water in front of the pour. It's a bond breaker that's waiting to happen. Plus, it compromises the quality of the mix at your interface there, basically, which is where you really need the good quality mix. That bond line is your most important area. So the contractor should have a couple shop vacs stationed in front to pick up that excess water. 2 is best, 1 on each side of the pour line. So some people like to, sometimes I'll see contractors using compressed air and just trying to blow the water around, and I just really discourage that. It just seems to make a mess. It's aggravating for the mobile mix operator, the laborers in front. It's just kind of an aggravation. So you really want to make them use shop vacs. On these hydroed surface in particular, there's a lot of areas where water can pond, especially when you get those variable depth depressions where you have reinforcing steel. So, make them use a shop vac and suck this water out. They need to be getting that out ahead of the pour that they're making. The finish machine should have a vibratory mechanism on it already, but also you need vibrators on hand where the finish machine's not going to be able to reach, like your curb line area, your joint areas around drains, those types of areas. Also, when you're pouring in those deeper variable depth pockets, it's good to hit those with the vibrator and consolidate it to a good tube before the finish machine runs over that area. If you don't do that, what you can get is a settlement in those areas as the finish machine is running over it. So the finish grade may get a slight depression in that area, so you kind of compromise your the surface quality right there. You get those depressions if you don't consolidate some mix in there ahead of that pour. For real deep pours too, if you're pouring maybe 3 inches or better, you're probably good to go ahead and vibrate the whole surface as well. You want to watch the rollers, make sure they're good and level. If you're seeing these tailings, it's obviously out of whack a little bit, needs some adjustment. When these rollers are not level or square, it's creating much more work for your finishers, obviously. So ideally, the less you have to touch that LMC, the better. Be aware that what's going on behind your rollers. There's going to be handwork along the edges, the curb lines, and you want to kind of discourage the finishers from being in the mix, working it. They really should be up on a curb line or a work bridge or a platform of some kind that's maybe attached to the finishing machine to help finish that area. Now, I think the North Carolina spec does a real good job addressing how to handle longitudinal joints for your stage construction. Just wanted to kind of stress the importance of the detail here. This is actually on an Illinois job. Reason I know is the fibers in it there. What I wanted to point out, though, is the slobbers there. Those all need to get removed. One trick I've seen is that where you have the overage pour zone, and that would be that 4-inch section where your spec says you're going to remove that. What I've seen is a contractor, he'll actually kind of lay some plastic down on the deck when he's pouring just in that overage area so that any of that excess concrete that is not adhering, you don't want that excess concrete adhering to your adjacent deck necessarily because you got to get that out of there, right? So when the contractor performs that saw cut and needs to remove that overage area with that excess concrete, now he can just pull his plastic back. He takes up all that concrete and he leaves the substrate fairly clean. He is going to have to do some final abrasive blasting there, obviously, but here the contractor's just created a lot of extra work for himself by not putting anything down to protect himself there. So what you're seeing in this picture here, the inspector has noted delaminations in the joint area. Well, guess what's happened here? What's happened is, come to find out, the contractor, he poured across this joint and then came back later and cut it. Bad move. Shouldn't do that. And your spec actually doesn't allow for that. So, but what he's done is he's caused a debonding to take place here because the joint was locked down when he poured across it now, and with temperature fluctuations it had to give. So it caused delaminations at his joint area. And so that's why you need to form your joints. You have to make sure they're able to move. So I wanted to summarize one more time with regard to curing, because it is so important to the process. In most cases, curing latex includes both a wet and a dry curing period. And this is going to depend on your cement type, obviously, that we talked about earlier. But the wet curing is one of the most important parts of the latex installation process, if not the most important part of the process. So I just want to kind of reiterate and stress the key things to keep in mind, such as don't delay in getting the burlap down. You know, the nice thing about you guys doing post-cure texturing is that if you're slightly marring that surface, the grinding, grooving operation is going to help to correct some of that imperfection for you. But it's better to err on the side of getting the burlap on faster than not fast enough. So as soon as that surface will hold the burlap, get it on, and before the latex forms that crust on it for sure, and is you know, trying to dry. So generally, like I said, about 30 minutes max, maybe faster even, and especially faster on rapid set. You're almost putting the burlap down behind the finishing of the surface, essentially. But make sure it is good and wet and applied to the latex. Don't let the contractor try to take that dry burlap or very, you know, moistened, just very lightly moistened burlap and then try to dampen it while he's putting it on. It needs to be good and soaked. Soaker hoses under the plastic, as conditions will allow, are helpful too. But also, both the burlap and the plastic then, you need to make sure is sealed up very securely in place along the edges and at the breaks in the material. So wind's not going to have a tendency to get under it and expose the burlap or the deck surface. So whenever you're in doubt, cover it up. So failure to properly cure is going to be the leading cause in allowing your shrinkage cracking to occur. So with that, a few pictures about burlapping issues. Here you can see the problem. Burlap is dried out on the deck. If you look a little closer, this is actually the same job. They don't even have the plastic on it yet, and it's drying out all over the deck. So the wind has blown apart the burlap. It looks like they're trying to get soaker hoses on it. Just poor job planning and covering of the deck here. They're way too late on this. You want to use good quality polyethylene sheeting, free of visible defects in covering. I think your spec says 4 mils min. One thing we see in other states is contractors trying to go to Berlin. I don't know if you guys are running into that or not, but kind of discourage that by the latex. The latex manufacturers aren't real key on that because usually you're trying to take that out there dry and put it on. That's what you don't want. You don't want dry material hitting your deck and having the possibility of trying to suck moisture out of that deck. Don't let the operation get too far apart. This can especially happen if the contractor doesn't have enough people dedicated to his operation. This is good here. You see the finish machine, finish operation, plastic, all real close together. Plastic's pulled up not too far behind it. Great job here by the contractor. Last thing you want to see is a contractor pour it out, and lo and behold, you look back, and they haven't even started curing or covering the deck. It happens, though, out there. There's some other random thoughts here. Be aware of structural cracking that may be evident in the deck you're pouring on. Are there traffic vibrations occurring within stage construction or noticeable impact loads? Especially if you're pouring on longer steel plate girders, there can be quite a bit of deflection in those. So truck traffic is the enemy here. It's what's going to be inducing the live loading, and it can hinder the setting of the concrete. So it's just hard for concrete to harden without cracking if it's going to continually be vibrated and moved around by the deck bouncing around. So Another good reason to pour at night. You can control traffic control a little better to help slow down traffic, trucks through the work zone and reduce the deflection and vibration. So be sure you have all the delaminations out of the deck. Pretty obvious there. Be smart. Use good concreting practices, both hot and cold. If you do get some shrinkage cracks, though, don't panic. Evaluate the extent of that, and really it comes down to bond. You know, if you have minimal shrinkage cracking, they can probably be treated with a sealer. Most of the time, these are surface type cracking from dry shrinkage, and they're not going to extend through your overlay. Just shortly, kind of a short distance down into it. So what this happens as the concrete dries out from the surface faster than how that inward concrete is drying. So sound your deck, make sure you have good bond. It might be that the treatment of the cracks with something like a methacrylate or a molecular weight methacrylate can seal the crack off from further infiltration or chemicals. Be aware of wider pores that can induce longitudinal pattern temperature control cracking versus more conventional transverse temperature cracks, and then make sure there's a go-to person on the job. I did slide a few slides in here. Tim had sent me, or maybe Randy and Tim, I guess, sent me a few slides here to kind of include in the presentation. Looks like a failure, and I guess I'd kind of say, you know, when you see failure like this out there, there's really only two things that can be happening. You either have an interface failure where that overlay has not bonded correctly, or you have a substrate failure. So that would have to be what your problem is there. It's either something got on there to prevent that bond, or the DLAM just wasn't out. There might be some microfracturing under it, and that kind of led to the issue starting to fester there. I think you see, when I see failures out there, a lot of times it's close to joints, because that's the hardest area to get good and clean and get the quality prep that you want. And then when you do get a failure area, it seems like it's really hard to shut off, because you just keep getting it raveling. It continues to ravel. One thing you can notice maybe when you have a failure is if you can look at the material at that failure point and see, is there material that's bonded to that overlay that is being pulled up from the deck, or does it look like you have a clean separation at the interface? Especially, and it's easier with like epoxy overlays. Like if you put down the thin epoxy polymer overlays, when you get failures in that, you can very quickly see in your epoxy, is there a concrete deck that's stuck to the bottom of that epoxy? Well, that tells you that the failure is below the interface, or is it just pure epoxy that you're seeing, which tells you that it's the bond line has failed. Same thing here, really, with your concrete. If you have some pieces of the failure, you can kind of look to see, okay, what did we have go wrong here? Was it the interface, or was it the bottom of the deck itself that failed below the patch? Probably mostly it's going to be the deck failure. If you have a hydroed surface, it's going to be unlikely that it's going to be an interface failure, unless you just had some contaminants or some poor cleaning that went on that led to it kind of failing at that point. This looks like probably moisture. You know, moisture probably gets down those joint areas, especially when you're using these polymer headers. You get that little there's that little gap there between the joint material itself and the overlay, so it's a great avenue for the water to obviously get right down there, and then it can start attacking freeze thaw issues there. Sometimes it's good in these types of joint systems, when you're done pouring, to just go ahead and lay a bead of methacrylate or something right along that seam. Just go ahead and lay it all the way along there right when you're done, just to kind of give it a kind of an additional measure of sealing at that location. Don't like to see this. Someone got out on the deck and walked through the overlay here. Unfortunately, the contractor had to cut all these footprints out and make repairs. And the bad thing is, even though he repaired it, you know, the quality's not going to be good. And these areas are going to be susceptible to future failure as moisture attacks it, and the bond just won't be the same. So bad news there. I'm going to close out here. I know I'm running late here as usual. I want to talk about cracking a little bit because I know that's probably a concern to you guys out there. We know concrete cracks, sometimes more than others, but why is it doing it? Well, probably most of the time it's going to be related to one of the items on this list here, especially where it's associated with the curing. Like I mentioned earlier, not a cause for panic. You don't like to see it. It's unsightly often, but you want to try to evaluate and react accordingly. Got a few examples here. This here looks to be a plastic type shrinkage cracking. You can see it's occurring at the start of the pour. It looks like they pulled off the header, and you can see discoloration in the start. So I'd say it looks like the mix was probably a bit dry and likely took a bit for the concrete to get covered and curing, especially, when you start off the pour, it does take a little while to get pulled away from there, and it takes time. And so I imagine there was some extra drying going on here, and it was already probably kind of dry just to start with, it looked like. So water cement ratio probably a little low and lacked that cure getting going immediately on it. This is probably what you see out there the most when you get the cracking. It often does not show up until the concrete really starts to dry out. So after the wet curing, and then the concrete undergoes the dry curing, and in doing so, no more water is being drawn down into the concrete now. So the interior part of that mix may have enough moisture, but that outer surface is drying. These are often the ones that are tough to figure. Usually these will be pretty fine and often confined to the top surface. So don't know that they are even really sealable in a lot of cases. This was a pretty wide pour here. This was over a 40-foot wide stretch of a pour. Long way to go for a finish machine to go across. So you can imagine the curing, getting that going, that's going to be delayed. Also in this particular pour, the water cement ratio was a little too low in my mind. I think it was down around 0.35. They probably could have used a little more fluid mix. I attribute this to something called autogenous shrinkage. And what that is a phenomenon that can happen with thin lift concretes that they have a lower water cement ratio, and they're placed on your in situ type concrete. What happens is the water is drawn quickly down into the hydration process, and it creates these real fine capillaries that kind of react back up to the surface. So there's also likely a significant change in temperature, I'm going to guess here, as far as during the cure period between daytime, nighttime temperatures, because it was in the fall. One of the things I noticed on this particular deck, if you looked at it in the summertime, the cracks are hardly visible to the naked eye at all. You can't even find them. The only time they're really visible is after a rain event or a foggy day, and that deck starts to dry out. You can just see the moisture wants to kind of hang around that crack area. Or when it's really cold, the cracks will be more noticeable too. So concrete expands, contracts with temperature, so they appear more readily in the wintertime when it is cold out. I've got a few here. These are structural cracks. Apologize, I'm running a little long here. Your overlay will not overcome structural cracking. On the left is a pour and an approach slab. One thing about approach slab pours is you need to make sure those slabs are good and tight. You need to mud jack under them or inject like an expandable foam underneath those to seal them up good, so they're good and tight and they're not going to vibrate or deflect under load. This probably did not show up, I'm going to guess, for a little while until traffic got rolling on it for a while. Good chance well after the contractor left with his taillight guarantee even. On the right is a classic example again of a contractor trying to pour through a joint and saw it later. Cracked on him before he got it sawed. For wider cracks, something like an epoxy type sealer, which is not quite as low viscosity, may work a little better for filling in a structural type crack. This one here is one I did out in St. Louis about 15 years ago. It's a rapid set job. I keep pretty close tabs on it. I noticed several of these structural type cracks though, like you see on the right side. The thing you have to remember is when we pour these decks back or these overlays back in a monolithic fashion, where we've demoed them, the overlay is now acting in concert with the deck. So it's acting as a single unit. So the deflections and the live loads are going to be reproduced through this. It's the same structural type crack that you have in your slab already. It's just a matter of time before it's going to show back up, because that slab is working and concrete cracks, and we allow it to crack. That's why we have reinforcement in it. So here we got just some more random structural cracking. This one on the right, I'd say, is more of a thermal type crack. This deck here had several small stray cracks in it. The contractor was able to just do some localized sealing of the cracks. Sometimes the cracking, and this is another rapid set job, you're probably finding rapid set jobs especially may be more susceptible to cracking issues. This one's a little more extensive. And when it's not practical to trace the crack with a sealer, it's more efficient to just do a total surface treatment of it with like an MMA or an HMWA type sealer. Let that sealer just soak down in and fill the cracks. Those sealers are going to be the lowest viscosity sealers you can use for fine penetration of cracks. So that's the type of sealing you want to do with these. Of course, you want to make sure bond is good and strong with the deck. That's the most important key. You can get if you get cracking, you definitely want to make sure you have good bond. If it's not too extensive, seal it. But if it's too extensive, the owner has the right to just say, you know what, I'm not accepting this. You're going to have to take it up, and that's a bummer. It happens, but sometimes contractors learn the hard way, and they have to pull them up and redo them. That's why you want a good, experienced contractor out there for these rapid set jobs, and glad to see you have that in your spec that you do require that. Quick summary. I'm not going to read. I'll let you guys read these because I know I'm running a little long here, but it's basic, just clean and prep and wet. That's the key, and if you do that, that goes a long way to getting a good quality installation. Couple resources to finish off here. BASF has a really good placement guide out there, and I'd call it kind of the Bible of latex. So lots of good information in it. It's got some FAQs in there. I've got a ton of these. If you need any, let me know, and I'd be happy to pass these on to your department. Just let me know how many you need. And then also, I want to plug our Latex Modified Concrete Working Group, just a group of what we would, I guess, term experts in the industry, work to provide education and training and information on proper installation for latex concrete overlays. And we're available to answer questions. So if you have a question, either before the job, during the pour, or after the job, send us an email. We'd like to hear about things going on, issues out there, anything we can do to try to provide information to help you guys out. So that is a group that's out there for your convenience. So please reach out to us if you have any needs. And with that, as yesterday, if you want a PDH for today, send me your request at my email address. And if you were on yesterday's, I'll probably just combine it into one PDH, so give you two there. And then again, the latex manuals, just email me, let me know how many you want, where to send them. I can get those to you. And with that, apologize that I ran just a tad over here. Trying to get back to my off my screen share here. Okay. Anybody want to try to ask a question here, or are you still there? See any chat, anything in the chat box? Anything I can answer for you?
Hey Pat, Tim here. Again, as with yesterday, great presentation, a lot of good information sharing. So we certainly appreciate you providing that for us. Like anything, whether we're doing an epoxy overlay or we're painting some steel or whatever, proper selection of materials and proper preparation of the substrate and application of the whatever we're putting down, all of that is super critical to having a successful job. And going over yesterday's hydro demo stuff and today's placement of the latex is super helpful for us. I don't care if it's brand new construction. There's going to be things that are missed and overlooked from time to time. And the photos that we shared with you after the presentation yesterday are examples of that. Randy has a good point. We spend a lot of money on these things, and we want to make sure they come out well. But sometimes the different variables involved, sometimes everything's not covered, unfortunately. But providing us with these tools and this refreshers, these tips, hopefully will help us to get some better projects going in the future. I would say our biggest problem areas are when we do the very early strength jobs where we have to turn the bridge over overnight, and that presents all kinds of problems where you're rushing, you're trying to hurry up and get that deck saturated as much as you can, and there's all kinds of problems that can occur whenever you try to rush things, of course. But we do the best we can, and I think I like the idea that we have with the early strength to kind of have some kind of middle road between the very early and a regular strength to try to mitigate some of those issues, but still return the bridge to service as quickly as possible.
Right. Yeah. So is that early strength mix, are you guys using that now, or is that one you're just developing?
We've used it a little bit, not a lot, but we're probably going to try to use that more. I know we probably did it first, probably, I don't know, 5-6 years ago, and seemed to have pretty good success with it. And we've been speccing that on a few. We've kind of tweaked the spec a little bit, and we've been speccing that on some more projects here lately. So it'll be good to see how well it goes on some of these more recent projects.
Yeah, and hopefully with the if you can do the weekend work where you have a little more time, that might be a little more favorable for you to use that mix. Where, like you say, if it's overnight, you're almost stuck with the VES mix because you got to have it open in your 10 or 12 hours. And when you start rushing like that, there's just a lot of shortcuts that are being taken, and it leads to issues often.
Yeah. And, especially when we have situations where we have an existing bridge deck that has an asphalt wearing surface on there, we don't know exactly what's underneath there.
Exactly.
It's hard to anticipate that. And so, especially if we have the asphalt wearing surface and we're trying to do a very early strength and we're trying to turn it overnight, that really causes problems. So
yes, right. I do see one question out there. Someone asked about fixes for cracks. Do you have a list of approved materials? I guess I might throw that over to you, Tim. Do you guys have a list of approved products for sealers? I know Trinzio, Sika, those are popular manufacturers and they have good quality products. I know there's others out there. Do you guys have a list of those?
Yeah, we have some of those. We've got a couple of specifications for high molecular weight methacrylates that even if we don't have, even if the particular product is not on our approved list, if it meets that spec, we're good certainly with that. We have some other sealers. One question I have, how do you feel about the use of silane on a latex deck for smaller cracks?
Oh, for the very small cracks. Well, if you have a lot of cracking, I guess maybe it would provide some benefit, short-term benefit. I mean, it's not designed as a crack sealer.
Sure.
Silane is not. So it's really a waterproofing material that's designed to go into to kind of the pores of the concrete. And since you really don't have pores with latex, it's just a densified concrete. It may have some very minimal benefit for cracks. I don't know though. I'm not sure about the viscosity on that. I haven't looked that closely at the viscosity of silane versus the methacrylates to see how they compare. I guess they're probably similar.
Yeah, I mean, it's super thin. It's going to penetrate a lot of those cracks. But back to that, the question: do you have any type of crack sealant products that you guys kind of do not like to see on a latex overlay?
Oh, I don't know. I mean, I think it's kind of the idea. Doing something's probably better than doing nothing. So no matter what product you're using, if you're doing something and it's getting down into the cracks and it's able to block, water and chemicals from getting down into, that's a good thing. So I guess it depends. You can spend more for a better product and it's probably going to get better penetration and better life. Or you can use a cheaper product that may give you shorter term life. So I think doing something's better than nothing if you can. But like I say, some of these cracks, they are very, very fine, and I'm not even sure how much penetration you can even get into some of the very, very fine cracks that you sometimes see out there.
Sure. Yeah, that's kind of my approach or my thought anyway. Is like things with the hem and different things like that are going to have limited effectiveness if it's a very small, narrow crack. And so that's where, the thought kind of turns to the silane.
Yeah.
That could, obviously it's not filling the crack, but it's helping to repel water from getting down into the crack. So.
Yeah, I could see there could probably be some short-term benefit there for that. A lot of times it seems like on these decks, you almost have to kind of let them get in service for a few years, and so you can kind of see how the cracks work, and then you have a better option to kind of seal them at that point. I know that's not a good thing because then then it's more on maintenance to do that than the contractor. So that becomes more work on your part is the problem there.
Sure. One question kind of related to Randy's issue that he brought up. It seems like we do the very best we can to try to identify delaminated areas that may have been missed after the hydro. Any tips on that? I mean, obviously there's things like, I guess, chain drag and, rod soundings and different things like that. Do you have a magical answer for that?
No, yeah, that's kind of what you see. It's basically seems to be that hand sounding method, which can be kind of hit and miss a lot of times. Yeah, I don't really have a lot of other good options for you there, I'm sorry to say.
Right. Well, and who knows exactly what happened. In some of those situations, it may have simply been that somebody kicked the plastic cover out of the way, and the mixer dropped some oil on the deck or something. Nobody cleaned it off. Who knows? I don't know.
Yeah, exactly. Yeah, I'd say one good thing that can be helpful too, like I kind of mentioned it yesterday, was documentation. When you do get everything cleaned up, try to get some documentation, maybe some photos and even just some random notes about where you have specific areas of failures that may be potentially a problem down the road. You don't know. So that's the thing. It gets hard when you try to play detective after you see the the failure areas. Then you're trying to recreate. Okay, now what do we have underneath? And you really don't know unless you have some good documentation of the area. So it gets hard to determine the root cause a lot of times because of that.
Yeah.
I think there was another question. It looked like somebody popped a question up there about penalties. Do you suggest penalties for problems with cracking? I have seen, and I don't know if that is necessarily a penalty spelled out in the contract as far as determining the amount of cracking or anything like that. But, you know, if the owner doesn't feel like he's got a good quality product and he doesn't want to accept the overlay, you know, it's within his right to reject it. But then a lot of times it gets into taking deducts. Okay, well, would you consider taking a deduct for the installation or the material? So I see that happen occasionally. You know, you hate to get into those situations, but that's probably what I've seen more than anything, more so than something written into the specification as far as a penalty, I guess, so to say. I don't know if there was, I don't know if I missed any other questions out there or not. Let's see anything else. All right, well, like I said, if you have things that come up in the field, you have questions, you can contact that working group. That's a good source, I think, to help you guys. We've got these manuals out there that are a good source. And if you have any other questions of me, please feel free to send me a note, give me a call, whatever I can do to assist. I'd be happy to do so.
Hey, Pat, this is Aaron Earwood. I just want to, again, thank you as well. And assuming the recording turned out and it actually recorded, we'll get with you and try to get a copy of that. And we'll try to find out how many people missed yesterday's and maybe possibly get you to represent that from yesterday's conference and record that. And then once we get both recordings, we'll make sure we get that distributed to all the offices or the engineers across the state, or post it somewhere so you have access to that for your folks that missed. But we do appreciate both yesterday and today.
Yeah, that's no problem. If I need to do an encore presentation there, I can do that for you. Not a problem.
Okay. All right. Thanks a lot.
Okay.
Thanks, Pat. We certainly appreciate it.
All right, guys. Thanks so much. And I think it was recording, so hopefully I can get that to you.
Super.
All right. Great. Okay. Thanks, guys.